Hello everyone, in this quick video we are going to discuss about data flow analysis in compiler design, and the outline of this video is going to be: first we are going to see why do we need data flow analysis, what is the importance, and we are going to do three analysis of data like live variable analysis, reachability analysis of the data element, and availability of the data element in each and every block of the code. And global data flow analysis, it is nothing but collecting information about the way in which data are going to be used in a program, and this is coming in target code generation phase, or we are going to optimize the intermediate code. For that we are in need of the flow of data from one block to another block, and we are going to take the control flow into account. So we are going to use control flow graph for our reference, and it is based on the syntax. And the data flow analysis is important for doing the optimizations such as constant propagation, common sub expression elimination, and partial redundancy elimination, etc. So it is important for us to analyze the flow of data and which are the blocks that are going to use the same data, and which blocks are changing the data which is defined in the previous block. All those will affect the target code. So we are in need of analyzing the flow of data from one block to another block, and this is how it is done. This is the basic representation of an algorithm. It is based on a block level information. Alright, so first we are having a variable change. We are initializing it with false, and we are going into each and every block now, and we will be executing the statements, or we will be analyzing the statement inside the block, updating in and out. So what do you mean by in and out? We will be seeing in the later part of our video. And if either in or out changes, then means the block changes some of the value, so change will be set to true, and this process continues. So which means this process will go into the next iteration, and it will do the same operation again. If there is any change, then it will iterate to the next block. If there is no change, it will go to the next block. Okay, this is how the data flow analysis is going to be done. So first is live variable analysis. What do you mean by live variable? And we'll be defining or using one variable here, and after some point we may not be using that variable anymore. So we can, which means we cannot say that variable is live anymore. Or if we are changing the value of that variable in some other block, so assume that this is block A and this is block B, and intermediate we are having some block X, and we are having a X, we are defining some value of a variable X here, and if this block, intermediate block, changes the value of that X, which means this variable will not be live when the control reaches this block, which means the value of that variable will be modified in between. So we cannot say that is not live. We can say that is not live, otherwise it will be live. The same variable will be having the same value even after reaching this block. That is meant by live variable. And a variable X is live at a point P if there is some path from P where X is used before it is defined. Alright, defined means the value of that variable is changing, and sometimes the information can flow backwards also. If you are having any loop or something, the control will be going back to some other block, some previous block, or to the start of the same block. That means the the information will flow backwards. And how are we going to analyze a live variable? And we'll be using different terms or different properties: def, use, out, in. What do you mean by def? If you are defining the value of some of the variables before using them, then it is that def of b will be true. B is a variable now. And use of b, if you are using the variable before defining them or before changing that value of that variable, then use of b will be true. Out of b, the value that is coming, that is live immediately after a block. Assume that you are in a block A, for example. Alright, the variables which are live, the values which are defined inside the block, will be available immediately after the end of that block. So that is meant by out of B will be true in that case. In of B, the variables which are going into the next block. Alright, so that is, or the variables, the values which are going into a block is known as in. And this is how we can understand by using this flow diagram we can understand what I mean by def and use. And here we are defining the values of a and b. So a is assigned with value 1, b is assigned with value 2, so def of a and b will be true. And use, we are not using any variable. Using means the variables will be available on the right hand side of the expression. Here in the block b2 we are having two definitions, d3 and d4. C is equal to a plus b. So means this d3 uses a and b, which are on the right hand side, and it is defining a variable c. So def value of this block b2 will be c and d, because we are defining the values c and d. Use, so we are using the variables a, b and c. So why are we not having use c in the case of use? Because it is defined before its first use. Alright, that's why we are having c only in the def part, not in the use part. And the block b3 we are defining value d, but def of b3 do not have any entries on the right hand side, because it is used before it is definition. So d is equal to b star d. D is available on the right hand side, so it is using d to define d. So it is used before the definition of d, so def will not have any values, but this statement uses b and d. So use of b3 will be b comma d. In the case of block 4 we are defining the variable d using a, b, and here e is defined with the help of the value stored in e. So use of b3 will have e also as an entry. So in the case of b5 we have two statements, d8 and d9. B is equal to a plus b. Here we are using a and b before its definition, and we are using c as well and defining e. So definition will only have the def of b5 will have only e, and use will be a, b and c. In the case of b6, if you follow the same properties or same procedure, we will be having b, d as use part, and a, it is defined before its usage. So use of b6 will have a as an entry. So this is how we will be finding e, use and def values of each and every block. And so this is in and out part, a, b, e. So here we are having a, b as the values that are going in, here a, b, c, d, e values that are coming out. So that is in and out of each and every block. So here we are giving a, b, c, d, e as input, means these variables are alive in this case, so that are going into this block, and these values are coming out of the block. So in of this block will be based on out of this one. So that's what is defined here. Out variables and in variables will be the live variables immediately after a block and immediately before the block. So in will be based on the values which are live before the block. Out of any block will be based on the live variables which are live immediately after the block. And this is how the in and out will be calculated. In of b1, out of b1, in of b1, out of b1. So it is based on the iterations. In the first iteration we will be having the similar simple values. If it is based on the control flow, we are having loops, and we are having loops from controls jumping from b5 to b3, b2 and b4 to b3. So based on that iterations you will be having different columns for in and out values based on each and every block. So the live variables or the data flow analysis will be done based on the block level information. So first we need to identify the basic blocks, and then the variables that are used, and the data flow analysis will help us to identify the pattern in which the information is flowing between different blocks. Then comes the reachability analysis. So definition of a variable is x is a statement that may assign a value to x. Means if you are storing or changing the value of a variable x, then we call it as a definition statement. Alright, so what do you mean by reachability? That is explained in the second statement. So a definition may reach a program point p if there exists some path from the point immediately following the definition p such that the assignment is not killed along that path, which means we are assigning some values to the variable x, and after some point if you try to access or use the same variable, if the value has not been changed in between, then this definition is reaching that block as well, means it is not killed in between. Here we are having different blocks. b1 uses I and j, and the value of I is changed here. So this, the value of this I will be killed immediately in the block B2 because I will be assigned with some other value. So this definition will not be having any effect on that. But J has not been modified in B3. So J can reach B3, but I cannot reach after B2. Okay, so this is what is meant by reachability analysis. If the values are not changed or not modified in between along the path, then you can say that value is reaching, that definition is reaching the next block. Alright, so reachability analysis, compute gen and kill at block. So gen means where it generates the value, and kill means when we are modifying the value in some other block, and it will be based on the in and out. If you are modifying some block or if you are changing the value in some block, then it will be subtracted from the in, because in will be having one assignment for one variable, and kill means we are changing some other value, we are modifying that value to some other value, so it will be using this kill operation. So the number of variables will be reduced because that value will be changing when the block completes its execution. So in will be based on the out of B if P is a predecessor of block P is a predecessor of block P, means we are getting input from block P to the current block P. So in of B will be based on the out of this block, but the out of this block will be based on the value it is generating or it is defining, and the value that is coming from the predecessor block, and minus the value which are modified this current block. Okay, this is how we'll be finding the reachability. And gen, the set of definition generated by B. Kill, set of definition that cannot reach the end of B, means see it will be getting the input for one variable, okay, but it is modifying that value, so it will not be the same value even after the block gets executed. That is the definition of kill. Kill of B means set of definitions that cannot reach the end of B. So so what do you mean by basic block? It uses kills definition, generate new definition. So here we have a simple statement, A is equal to B plus C. It means this statement uses the variable B and C, and it kills all definitions of A. What do you mean by that? Here we are assigning a new value for this variable A, which means all the definitions which are made for this A in previous predecessor blocks will not have any effect because A is getting assigned with some other value. So the kill of definitions of A is happening here, but it generates a new definition for A because it assigns a new value in this block. So it uses B plus C, it kills the previous definitions, and it generates a new definition for the same variable A. And here comes the example. So block 1 we have three definitions, D1, D2 and D3. So it defines the value of I, J and A. So B1 generates the definition of, so it generates 1, 2, 3. Okay, and what do you mean by kill of 4, 5, 6 and 7? Because D4 uses a definition I, 5 uses a definition of J, means it generates or assigns a value to J. All those definitions will not have any effect here, so it kills these definitions. And 6 and 7 also it uses A, it uses I. So all those values are modified here. So all the definitions that have happened in D5, D4, D5, D6, D7 will not have any impact here. So it generates 1, 2, 3, but it kills all other definitions. In here it generates 4 and 5. I and J, it was generated in this block in statement 1 and 2. So it will be modified here. So it kills 1, 2 and 7. 7 also uses I, so it also kills that definition because it is modifying the value of I. In the case of B3, it generates a value A, it kills the value that was assigned to A in this statement 3, so kill of this B3 will be 3. In here it generates a value in statement 7, but it kills the definition of I. The definition of I happened in D1 and D4, so it kills 1 and 4. So this is what you mean by generates and kills property of the statements in each and every block. And reachability analysis, in and out for each block in forward direction. So it will start with in of B as null, and if it is, and it will be the union operation will be made between this in of B with out of B. If P is the predecessor block, whatever is coming out of that predecessor block will be coming in as the input of this block. So in of B will be based on union of out of B, and out of B, output of the current block B will be based on the value which are generated by this current block and the in of B minus kill of B. So it will be getting some inputs from the predecessor block, and it will eliminate the values which are killed by the current block, so minus kill of B. So if you made an union operation between these two sets, that will give you the value of out of B. Okay, so this is how it is done formally, and in of B will be based on the union of all out of B. So out of B will be based on gen of B union in of B minus kill of B. This is a formal way of defining or finding the in and out value of each and every block, and it uses the generates and kills property of that is operations that are happening in each and every block. And this is how it is done. In will be initially null, and out will be 1 2 3 here, 4 5 here, 6 will be coming out, and 7 will be coming out. In the next iteration, the in will be null because first block does not have any input at all, and out will be 1 2 3, and since we are having a loop, the in and out value will be changing in the next iteration. So you will be keep on making the union operation in different steps. So this is how we will be finding the live variables reachability, and we will be doing the live variable analysis, reachability analysis, etc. for data flow analysis. And based on this control flow and based on the flow of information, we will be generating the target code for optimization. That's all about data flow analysis in compiler design. Thank you for listening.